All right, we are back for another Ohio State test standard review. Today we are doing standard 8.G.1. This is the start of the geometry standards, and this focuses a lot on transformations. So let's talk about the four types of transformations. We have translations. Translations are essentially just slides, right? You take a shape, the shape just kind of moves. Think of it like just taking a chair. If you got out of your chair, right, and you just moved your chair over to another desk, nothing changed about the chair, still facing the same way. It's just under a new desk now. That's a translation. Reflections. That's like looking into a mirror, right? When you reflect something, it changes direction. Okay, so think about how if you look at yourself in a mirror and you raise your left hand, your reflection is going to raise your right hand, right? Or what appears to be its right hand, because that's how the reflection works. We have rotations. I mean, that's just, I don't know how to describe it besides a rotation. It just kind of like flips. It turns, so it would look like this now. Like, think of like if you push, like if you ever watch like a cat push something off of a shelf and it's standing upright, and then all of a sudden it just falls and kind of like spins while it falls. And and then we have dilations. That's size changes and all that. And the important thing to know about transformations is that three of the four transformations keep shapes congruent. Congruent means the same sizes, the same lengths, the same angles. The only one that doesn't is dilations, which makes similar shapes. That means that, it's like same ratios, but it's not the same size. So with that background knowledge, let's get into number one. Quadrilateral ABCD is rotated about point P to create quadrilateral EFGH. So when you talk about shapes, okay, when you name shapes, the order matters. By which I mean, I should be able to redraw the original shape. Hopefully, you would do it better than me. And instead of A, because A is the first letter listed, it would be E. Instead of B, which is the second letter listed, it would be F. Instead of C, which is the third letter listed, it would be G. Instead of D, it would be H. Okay? So you should be able to recreate the original shape just based off of this. And the reason that we're doing that this way, instead of just trying to compare off of this, is this makes it a lot easier to see what lines match up where. Okay? Because remember, rotations, everything's congruent. So, AB is congruent to EF. So here's line AB, and here's line EF. It's the same line. So you check it. And note that these are select all. Select all means more than one right answer. DA, that would be this line. I'm gonna actually change the color for this question. DA, which would be this line, is congruent to GH, which is this line. Is that the same line? No. So that goes away. CD, which would be this line, is congruent to FG, which is this line. Is that the same line? No. So that's not an answer. BC, this line, is congruent to FG, this line. Is that the same line? Yes. Check it. CD, that's this line, is congruent to GH, which is this line. Same line? Yes. Check it. That's it. Even if they give you a rotation, if they give you a reflection, whatever, if they want you to just compare which sides are congruent and which aren't, just redraw the original shape with its new point labels and use that. Triangle ABC is rotated and then translated to create triangle DEF as shown. Rotated and translated. Congruent, congruent. That means your side lengths are not changing. So we're going to do the same thing we did last time. We're going to recreate the original shape. So A is our first one. So A becomes D. B becomes E because it is our second one. And C becomes F. And because these are congruent, the measures stay the same. And it says, what is the length in inches of EF? Well, EF is this line right here. 6 inches, 6 inches. Done. Recreate your original shape. Penny has a pool in the shape of trapezoid ABCD as shown with lengths in feet. Ben has an identical pool, trapezoid EFGH, but it is rotated as shown. Guess what we're going to do? We're going to redraw the original shape with the new labels because this has worked out well for us. So A is our first one, while E is his first one. So A becomes E. I'm taking out this A and putting E where A was. B is our second. F is our second. So F goes where B was. C is our third. G is our third. So G goes where C was. And D is our fourth. And H is our fourth. So H goes where D was. So it's rotated. Rotated means congruent. So that would mean that this is 6, this is 5.3, this is 10, this is 5.8. And it says, what is the length of side EF? EF is this one, which is 5.8 feet. You don't have to wrap your mind so much about what the transformation is doing to a shape if you can just recreate the shape. The only time you can't just recreate the shape is on a dilation. As long as they name it. If they don't name it, then we're in a bind. So on that note, here's a situation where we didn't name it, right? So, a series of translations, rotations, and reflections is applied to triangle 1 to create triangle 2 as shown. What is the measure in degrees of the angle X? So here's something you have to remember about this. Triangles have an internal sum of 180 degrees. So our first step is we need to figure out what this angle is. Even though that's not X, we need to figure out what it is. Okay? So, to do that, we add 57 and 42. So we go to our calculator. 57 plus 42 is 99. And then you subtract 99 from 180. And whatever remains is the angle measure. So that's 81. So this angle right here is 81 degrees. Now a bit of notation here. Whoops. The fact that this has 2 and this has 1 and this has none when it comes to arcs means that these sides or angles are not congruent. Okay? So this 81 represents the angle between the 7 and the 8. Let's say that this was, let's just call it, well, no, we're using X. Let's call this side length Y feet. So here's 7, 8. That would mean that this length would be Y feet. Your angle here between the 7 and 8 is the same angle as right here because it's between 7 and 8. Okay? That's what you're looking for. So this angle is 81. Therefore, this angle is also 81. So it's 81. So again, in case you missed it, we found 81, right? And then what I correlated, or what I found, was that the angle we were looking for right here is the angle that is at the meeting point of the 7-foot side and the 8-foot side. It's where the 7-foot side and the 8-foot side meet. Here, the 7-foot side and the 8-foot side meet here at the angle we found to be 81 degrees. Therefore, it is 81. A company created a logo using two hexagons as shown. Hexagon PQRSTU is a translation of hexagon ABCDEF. Well, this is nice because we don't even need to recreate the old shape. It's literally just recreated for us. All you gotta do is fill in the side lengths. It's the exact same shape. Because it's congruent. Because it's a translation only. Translation means they just took it, they moved it. To put it in SpongeBob terms, they took this hexagon and pushed it somewhere else. So what is the length of line segment? TS. TS is down here. It's 4. That's it. Pentagon A is rotated 180 degrees about its center and then translated to create pentagon B. What is the value of X? So, it's rotated 180 degrees and then translated. That means it's congruent. Okay? So all you have to do is you have to pick up on little clues. Okay? So, I'm looking at, when you see a pentagon, the unique thing about the pentagon, right, is it has a distinct point at the top. It has a point at the top. It has a point at the top. Think of it like when you get a box and it says this end up. It has that point at the top. So what this tells me, and you could even, like, I can't do it on my iPad because my iPad will auto-rotate, but you could even just, let me actually do this. Actually, I could do this. I just got to draw over it. This is X degrees B. So I've made a copy of this shape. Okay. You could take this shape and you could just turn your paper over. And you can go, okay, this is my original shape. I'm looking for the angle that is to the right of the point. The angle to the right of the point. So here's the point. The angle to the right of the point is 110. It's 110. That's it. An architect designs floor plans for 2 houses. The floor plans for the houses are shown. House B is a reflection of House A. What is the value of X? So remember, house reflection is just like looking in a mirror. Okay? And if you think this question looks simple, it's because, in a sense, it can be, depending on how your mind works. This could be incredibly simple for you, or it could just not work out for you. Okay? What I'm seeing here is that the side that we're trying to identify is what is easily the longest vertical side. Which one of these is the longest vertical side? It's this one. It's 39. The answer is 39. That's it. Quadrilateral MNOP is reflected over a line translated up. What is the value of X in degrees? Okay. So, this is a little bit different, okay? Because we can't just redraw the original shape and know which one they're talking about with X. So we have to, again, this is the math version of using your context clues. And I know how much Miss Files loves to talk about context clues. Okay? So what we have here, we have an obtuse angle. Remember, an obtuse angle is an angle more than 90 degrees on the short side. We have an acute angle, an angle less than 90 degrees on the short side. And we have 2 acute angles on the long side. Actually, these are both obtuse angles. Excuse me. Mr. Dietz, what are we doing? Oops. So we have one angle that looks significantly more obtuse, right? This looks like this, while this one's more like this, okay? So I'm going to compare, does this look like the more obtuse angle or the less obtuse angle? This looks like the more obtuse angle. So it looks closer to angle N, which is 130 degrees. Problems like this, like I said, it all comes down to how your mind works. Some people can just see it. Some people can go, okay, this is the long slant. That is NO. That's the long slant. This is the steep slant. That's MP. So I'm looking for angle N because it's the top of the long slant, which is 130. Some people, it just works. Okay? But you got to try to use whatever clues you can. Reflected. Reflected means it's flipped. Whatever was on the right side is now on the left. If your reflection raises its left hand, that means you're raising your right hand. It's all about those clues. Isosceles trapezoid ABCD is shown. It is rotated to create trapezoid EFGH. So let's do that. We're gonna draw ourselves a trapezoid. Here we go. Bam, bam, bam. I'm just the greatest. All right. So A is our first letter. E is our first letter. So we're going to replace A with E. B is our second letter. F is our second letter. We're going to replace B with F. C is our third letter. G is our third letter. So we're going to replace C with G. D is our fourth. H is our fourth. Replace D with H. Which statement is true? Okay. EF is parallel. Remember, this line means parallel to HG. Okay? So remember the notation for parallel lines. They're the little arrows here on the line. If you have an arrow like that on the line, that means that they are parallel. Does EF and HG have those lines? No, so it's not A. Angle A is congruent to angle F. So again, congruent comes down to these little dash marks. If you have an angle like this that has one dash mark, and another angle like this that has one dash mark, even if you don't know what the measures are, the fact they only have one dash mark means they're congruent. But if you have an angle like this with one dash mark and an angle like this with two dash marks, then these are not congruent because they have different numbers of dash marks. So angle A has one dash mark. Angle F, which is where B would be, has two dash marks. So no, they're not congruent. Angle B is congruent to angle H. So angle B has two dash marks. Angle H would be down here where D was. That only has one dash mark, so that's not congruent. Side FG is parallel to EH. These are parallel. They both have that parallel line or that parallel arrow on their line. So that's it. Two quadrilaterals are shown where quadrilateral EFGH is created by reflecting quadrilateral ABCD across a line and then rotating it. What is the value of X in units? All right, so let's do this. We're going to do our old favorite. We're going to recreate the original shape. So in the original shape, A is the first letter, E is the first letter in the new shape. So A becomes E. B is second, F is second, so B becomes F. C is third, G is third, so C becomes G, and D is fourth, and H is fourth, so D becomes H. And then we're going to copy the measurements, because again, this is just reflecting and then rotating. Reflecting is congruent, rotating is congruent. So what is the value of X? X is in between E and F. In between E and F is 6. Call it a day. So that's our introduction to transformations. I hope that was helpful. I'll be back with another standard shortly. Until then, good luck on your state test.